everybody, and welcome to this video on summation notation. In this video, we're having a look at calculating sums. So over here, we have the summation formula, and then we have to calculate what is that sum equal to. So what we're going to first have to do is we're going to have to determine what type of pattern it follows. And if it follows an arithmetic pattern, then we're going to use the arithmetic formula, and if it follows the geometric formula, then we're going to have to use the geometric formula for the sum. So we're going to have to find out what type of pattern it is, then we're going to have to find out what is in the number of terms. So to get the number of terms, we'll say the top index, so what's on top of the summation, minus the bottom, what's at the bottom, plus 1. So just remember that little formula. That's how we determine the number of terms. It's the top minus the bottom plus 1. I know in the case where we're starting at 1, then it's just whatever's at the top, but sometimes they sneaky and they start the sequence at a different term. We get our A by substituting the bottom index in. So we substitute where we're starting to get into that formula, the TK formula, to find out what's our first term. And then to find out what's D, if we have the linear pattern, it's the coefficient of our index. And to determine what's R, it's the base of our index. So one is a linear function of the index and the other one is an exponential function of the index. And the base is the R and the coefficient is the D. Okay, so here are a few examples. Let us identify which type of pattern this is first. So just by looking at it, you should know what type of pattern. So this one here, you can see it's a linear function of our index. Our index is K, so that means this is a linear pattern. And you can even tell you what's the common difference. It's the coefficient of our index, which is 3. This one here, our index is in the exponent, so this one is geometric. And we can even say what our common ratio is. It's the base of our exponent, which is 2. This one here, it's not linear or geometric. There's no index there. It's a constant. So it's a constant sum. We're summing the same number over and over and over again. So here let's start with the first one. It's a linear pattern. We needed to find out what's A, N, and D. So D is the coefficient of K. N is the top index. So 20 minus the bottom 1 plus 1. So it's 20. And our A is if we substitute the bottom index in. So 3 times 1 minus 1, which is 2. There we go, we have our 3 things, so we can use the SN formula. SN, we're using the one for an arithmetic series, is 2A plus N minus 1 times D. So now we're going to substitute. We are calculating S20, and that's 20 over 2 times 2 times A, which is 2, plus 20 minus 1, which is 19, times our common difference, which is 3. So then what we can do is we can type this into our calculator. And then what we end up is that the sum is equal to 610. So we evaluated that summation notation. Let's have a look at the second one. So this one here, we know it's geometric because the index is in the exponent. Okay, we know that our ratio is 2 because that's the base of our exponent. So now we need to find out what's in. So in is the top minus the bottom plus 1, which is 7. And then we need to find out what's our first term. It's substituting the bottom index in. So 2 times 1 plus 1, which is 2 squared, which is 4. Now that we have that, we can use our formula. This time we're calculating an arithmetic sum. So we're using a geometric sum. So we're using the geometric formula. So this here is 4 times 1 times 2 to the power of 7 all over 1 minus 2. Typing that into your calculator, we get that that is equal to 508. So that is that sum. It's equal to 508. Let's look at the constant one. So the constant one, if you can imagine, it's 1 plus 1 plus 1. And we have 100 of them because we're summing 100 terms. So what's 1 plus 1 plus 1 plus 1 plus 100? It's just 100 times 1, which is 100. So that's why you need to use your logic to get that, because there's no set formula. Or well, it's actually there is. The sum of a constant is n times the constant. So the number of terms times the constant. So there's 100 terms. Our constant is 1. So it's 100 times 1. So there we have it. Please make sure that you've understood this video. It's a very important thing to know how to calculate the sum if you're given the summation notation. The first thing is to find out what type of sum to determine which formula, and then find out those elements from that formula. Thank you for watching, and please watch our other videos on summation notation. Thank you. Bye.